Hello, today we're looking at lesson 4. We're going to talk about hyperbolas. A hyperbola is the set of all the points in a plane that have a distance from two focal points where that distance is the difference between the 2 points. The fixed points are the foci of the hyperbola. And the line through the foci is again called the focal axis. Any point on the focal axis that's midway between the foci would be the center of the hyperbola. And the points where the hyperbola intersects its focal axis will be the vertices of the hyperbola. In this exploration, we're going to again label our vocabulary terms so that you become familiar. So again, here's the focus, and here's another focus. And the point midway between those two focal points, that's the center of our hyperbola. And these would be our vertices, the major vertices right here. And then this part and this part, those are called the branches. That's what actually makes the shape of the hyperbola. And our focal axis would be the y-axis in this case. And then a chord is any line segment with endpoints that are on the hyperbola. The chord lying on the focal axis connecting the vertices is called the transverse axis. So that would be 2a. In this case, this would be the a value, and this would be the a value, and that would be the transverse axis. In this second picture, we're going to draw a rectangle around the vertices and the b value. And you'll find out as we go through this lesson that this will be the approach you want to take when you're actually trying to sketch one of the hyperbolas. So this would be the b value. It's the conjugate axis, and the b value is just one b value is the semi-conjugate axis. The whole axis from this point, this vertex point to this vertex point, from there to there, would be called the conjugate axis. That would be 2b. This is the semi-conjugate axis. And the transverse axis from this vertex point to this vertex point, that would be our a value. And just one a value would be from the center to any particular vertex would be called the semi-transverse axis. So 2a is the transverse axis, 2b is the conjugate axis. These are our focal points again. And what else are we missing? I guess we've covered everything, haven't we? So this point, this vertex would be a0, and this vertex would be negative a0, and this would be our focal point, c, negative c0, and this other would be our focal point, positive c0. And then we don't know these values, 0b and 0 negative b. So let's give a few of these a try. I'm going to leave this reading to you for how to go about sketching hyperbolas. I'll model it in our examples as we go along. This first example, before we graph, we're going to look at writing standard form of the hyperbola and then using that standard form to find the vertices. So similar to our ellipses, the only difference here is that we've got the squared terms have a difference by the definition of a hyperbola. And 9 divides 144 16 times, And 16 divides 144 9 times, and then 144 divided by itself is 1. So we know that the center is centered at the origin in this case, since we only have a single variable up here in our numerator. And the thing that I want to point out to you is that the first term in this case is x, so our hyperbola branches will be centered on the x-axis since x comes first. So I would think about my hyperbola going this way, where the branch would be here, and the center would be the origin. So if you're thinking about the vertices, the a value would be 4. So if a is 4, then our vertex point would be here at 4, 0 and negative 4, 0. So those would be our major vertices. And then the minor vertices would be the b value. So here the b value is under the y, and the y is 3, which puts our vertices at 0, negative 3, and 0, positive 3. And then similar to the ellipses, since our formula had subtract in it, then we're going to add the a values, the a squared and the b squared, to get the c squared. So a squared and b squared gives us c squared, which is 16, 25, and c would be 5. So our c value would be 5 units away from the origin. So the focus points, the first focus would be at 5, 0, and the second one would be at negative 5, 0, since we go focus, vertex, center, and then vertex and focus. So the two foci would be negative 5, 0 and positive 5, 0. So just algebraically putting it all together, that's pretty simple, straightforward. Now this one we'll graph. So we have x squared over 16, but we've moved our hyperbola off of the origin and moved it to the left 2 units, which leaves our hk value at 0 and negative 2. And again, my first term is what determines the a value in the case of hyperbolas. So our a value is going to be 4, and our branches, we're going to be centered on the x-axis. The foci, we're going to add up, well, let's see, our b value is 3, which would go up and down, and then 16 plus 9, the square root of 25, gives us 5, and it's paired with the a. These two go together, the a and the c, whatever direction, and the b is the opposite direction. So let's see what's going to happen. We're going to go over here to our graph. Here's my box. So if I go to the right 4 and to the left 4, we're moving that direction 4 off of the center. So our center, we said, was at 0, negative 2. And if we go to the right 4 and to the left 4, you can see where our vertices are. And if we go 3 up and 3 down, you can see where the minor vertices are located. So going back to our previous screen, we have a vertex at 4, negative 2, and at negative 4, negative 2. And then the foci would be 5 away, so 5, negative 2, and negative 5, negative 2. So 5, negative 2, and negative 5, negative 2. And then the asymptotes, we want to find the slope, so I'm going to use the graph to get the slope. And the slope of each asymptote is going to be the rise of 1, 2, 3, and the run of 1, 2, 3, 4. So we can do that off of the graph itself. So rise over run is 3 over 4. And actually in this case, you can see the y-intercept is at negative 2. So we could say the asymptotes are located at positive or negative, slope 3/4 x minus 2, since that's the y-intercept. And then the last thing we have to do is to follow the asymptotes and draw our branches, one on either side through the vertices. So very carefully through that vertex point. And this is one of your focal points. And then this is the second focal point, and there's your branch over here on this side. So drawing that box is one of the helpful hints for how to sketch a hyperbola. On this next slide, you can see all of the details about the hyperbola whose center is either at the origin 0, 0 or has been moved off the origin to some other HK value, some other point for the center. And here's the same picture, only this time the branches are vertical. And you should turn the camera off, copy these notes into your notes, these formulas, and then when you're done, come back to join me for the next example. So here in example 3, we have a picture of a graph, and we're going to write the equation based off the graph. So you can see the A value is centered on the x-axis, and it looks like we're 3 units away from the center. So we're going on the horizontal. The branches are located on the horizontal. The B value is 1, 2, 3, 4. The B value is 4, and it's vertically. And then the C value would be out here somewhere. So if A is 3, A squared is 9. And if B is 4, B squared is 16. So our C squared is also going to be square root of 25 for C, and it would be 5 away from the center. So if we're 3 away here, there's the first focal point, and if we're 3 from the center here, then 2 more would give us our second focal point. So the center looks like it's located at 2, 1. And this first focal point is located at 7, 1. And the second one looks like it's at -3, 1. And then we need the asymptotes, so where rise is 1, 2, 3, 4, and run is 1, 2, 3, so B over A. And we need the equation. So since the A was centered on the x-axis, we have x minus h squared over a squared, and then we have y minus k squared over b squared, and that's always equal to 1. Be sure to remember it's an equation, so to write the equals 1, don't leave that out. And then what else? We got to finish up with our asymptotes. So the asymptotes, we said the slope was b over a. So we have y minus 2 equals the slope, so plus or minus slope 4/3, and then x minus 2. Okay, so that was pretty straightforward, not too hard. Example 4, if you want, you can try this one on your own and come back to see if you worked the way I did. So in this case, we want to find the equation in standard form for a hyperbola whose transverse axis endpoints are located at -1, -3, and -1, +7. So you notice that the x value are the 2 constant terms there. So that's telling me that we've got the x is being held constant. So we've got a point here and a point here, and our branches are going to go vertical in that case. And the conjugate axis is 8, which means that our center is going to be 4 away from either one of those points. So our A value Actually, our center is going to be there. Or is it length 8? Let's see. Take that back. I'm not reading carefully. It said conjugate axis, not the transverse axis. Conjugate axis. 4 away here and 4 away here. Because the distance between the 7 and the -3 is 10. So that's 5 up and 5 down. Our A value is 5 and our B value is 4. So when we square A squared and B squared, we've got 25 plus 16. So our C value is the square root of 41. And that would go up and down as well. And on my calculator, the square root of 41 is about 6.4. Okay, so putting all of this together, we've got -1, 2, and then I'm going to go over to the graph and take a look at what's happening to come back and fill these two in. So we've got a center at -1, 2. We've got this point up here at -1, 7, which is where one of our branches goes through that main vertex, and then through -1, -3. So the two vertices are where our branches are located. And then the focal point, the first one is going to hold -1 steady, but we're going to move up. We're going to move up from the y value. So x will be -1, but the y value will be 2 plus the square root of 41. So 6.4, almost there. And then 5, 6.4, almost there. So our focal points, one of them is going to be -1 and 2. We're going to subtract the square root of 41. And this one would be -1 and 2. We would add the square root of 41. So we can go back and finish those out. And then the rise over run would be 5 on the rise and 4 on the run. So the focal points were -1 and 2 plus the square root of 41, and then -1 and the y value minus the c value. And the asymptotes, y minus 2 plus or minus 5, y minus 2 equals, getting ahead of myself here. Y minus 2 equals plus or minus the slope, 5/4, x minus -1. So our asymptotes are there. And then the equation itself would be y minus 2 squared over 25 minus x plus 1 squared divided by 16 equals 1. Now, just a word of caution, you notice that I'm using the a value is the first term. The first term was y because our branches were centered vertically. We're on our transverse axis is a y-axis at x equals -1. So I had to put my y minus k and then the x minus h. So y minus k was 2, and x minus h was -1. The a value squared and the b value squared. So you got to be very careful on the hyperbolas not to mess that up. It's different than the ellipses. And then back to eccentricity, we recall from last time eccentricity is c over a. And in this case, we're going to complete the square. So I'm going to factor out a 4 from both of the x terms, so 4x squared, and 4 times 4 is 16. And completing the square, half of 4 is 2. 2 squared is 4, but we're adding 16 on the left side. So I want to add 16 over here after we move that 164 over. And then doing the same thing, we want to factor out a negative 9 from the y term. So factoring out that negative 9, we got y squared. And this would be negative 9 times positive 8 would factor out that negative 9 from that term. And then completing the square again. So half of 8 is 4, and 4 squared is 16, but we're not just simply adding 16, we're adding 16 times negative 9, so we're really adding a negative 144 to the left, so we want to subtract 144 because we're subtracting with that negative on this side. Okay, so cleaning that up, you've got x minus 2 quantity squared and y plus 4 quantity squared, and 164 minus 144 plus 16 looks like we are left with 36. And then dividing every term by 36, 4 divides 36 evenly 9 times, and 9 divides 36 evenly 4 times. How convenient all that works out. And 36 divided by itself. So now you can see what comes first. The x value comes first. So our a is going to be 3. And our b is going to be 2. And 9 plus 4 gives us c is the square root of 13. So putting all that together, our major vertices are going to be located at, draw a little sketch here. If this point here was our center, which was located at 2, -4, and I'm calling this my focal axis, or my transverse axis, and I've got a branch over here, and a branch over here, and one of my focal points are here, and another one is here. If this is the center, and the a value was 3 away, what's moving? That's going to move the x, right? So 2 plus 3 gives me a major vertex at 5, -4. So the y is being held constant here. And 2 minus 3 gives us an x value of -1 and holding that constant y value. Same thing on the focal point. If we're adding the square root of 13, we're adding it to the x. So we're getting 2 plus the square root of 13, and the -4 y value stays the same for the first focus. And then to go to the left, we'd go 2 minus the square root of 13 and down 4. And then the asymptotes, that would be the b value over the a value, because we would rise 2 and run 3. See, the rise over run, because the b value was 2. So our asymptotes would be y minus k, and k was -4, equals the slope in both directions. So that would be rise over run 2/3, and then x minus h, and h was 2. And the eccentricity would be the c over a. So the c was square root of 13, and the a was 3. This was our a value. And that on my calculator figures out to be about 1.202. And I believe that's the end of our lesson. See you next time.